All right, let's dive in. Today, we're going to talk about a language that is quite literally everywhere. It's running silently in the background of our digital lives, powering massive enterprise systems, even the games on our phones. Yep, we're talking about Java. Just think about it for a second. What's the one piece of tech that's so widespread, it's behind your bank's website, your favorite Android games, and so much of the internet itself? I mean, really, what connects all of that? Well, you probably guessed it. The answer, in a huge number of cases, is Java. And the story of how it got to be so dominant, well, it's pretty fascinating. So, our story actually starts somewhere you might not expect. Not with the internet, but with television. Yeah, that's right. Back in the early 90s, a team of engineers got together to create a brand new language for smart devices, things like set-top boxes for your TV. It was a super advanced idea for the time, kind of like a solution that was just waiting for a problem to solve. And then, bam, the internet exploded onto the scene. It all kicked off in June 1991. A small, scrappy team of engineers at Sun, nicknamed the Green Team, started this project. Their creation went through a couple of names. First, Green Talk, then Oak. Kind of cool, right? But the real game changer, the moment everything clicked, was 1996. That's when they released the Java Development Kit 1.0. And just like that, this language that was originally meant for TVs found its true purpose, powering the wild, growing world of the internet. So why was this such a big deal? Well, you have to remember what things were like back then. The internet was this chaotic mess of different computers. You had PCs, Macs, Unix systems, all speaking different languages. If you wrote a program for a PC, that's where it stayed. It couldn't run on a Mac. It was totally platform dependent. And then Java comes along with this revolutionary promise. Write once, run anywhere. The idea was you could write your code just one time, and it would run on any machine. How? Because of a special piece of software called the Java Virtual Machine, or JVM. Think of the JVM as a universal translator that lives on each computer. It takes your Java code and translates it on the fly for whatever machine it's on. This whole write once, run anywhere thing, it was an absolute game changer for the internet. Now, to pull all this off, Java was built on a really powerful philosophy, one that was totally changing how programmers thought about building complex software. At the very heart of Java, its secret sauce, if you will, is something called object-oriented programming. You'll often hear it called OOP. So, what is OOP? At its core, it's actually a pretty simple idea. It's all about managing complexity. Instead of just writing long lists of commands, OOP tries to model the real world. You design your programs using concepts called classes and objects, which we'll get into. And the big win here is that it makes it so much easier not just to build the software, but to keep it working and update it later on. Okay, so OOP basically stands on a few key pillars. First up, you've got encapsulation. The easiest way to think about this is like putting your data and all the tools that work with that data inside a little protective bubble. It keeps everything safe and organized. Then there's inheritance. This is super cool. It lets you create a new thing based on an existing one, kind of like using the blueprint for a standard car to design a new sports car model. It saves a ton of work. And finally, you have polymorphism. This one sounds complicated, but it's basically the magic that lets a single play button work for a song, a movie, or a video game. It's the same interface, but it does different things depending on what you're using it with. All right, let's zoom in on the most fundamental building block in this whole object-oriented world, the class. And the best way to understand it is with an analogy. Imagine you're a builder. If you need to build 100 houses, you're not going to draw up a new plan from scratch every single time, right? No way. You start with one master blueprint. Well, in Java, that master blueprint, that's the class. And this quote right here just nails it. A class is the set of plans. It's not the actual house you can live in. It's the detailed drawings that define what makes a house. How many rooms it has, what the roof is like, all those details. Okay, let's make this super concrete. Forget houses for a second. Here we've got a class, our blueprint called vehicle. You can see right there in the code, it lays out the plan. It says that any vehicle we create from this blueprint is going to have a spot for how many passengers it can hold, how much fuel it has, and its miles per gallon. That's it. That's our master plan. So we have the blueprint. Now what? Now we actually build something. See this line of code? This is us telling the factory, hey, use that vehicle blueprint and build me a minivan. And just like that, we've created an instance of the vehicle class. We now have a real, tangible object that exists in our program. And that's the whole loop of OOP right there. You go from a blueprint to a real thing. Okay, so beyond this cool object-oriented philosophy, Java gives programmers this absolutely massive toolkit to build powerful, reliable applications. I'm talking about everything from the back-end systems for huge websites and big data processing, all the way down to the Android apps running on your phone. It's everywhere. So let's just take a quick peek at a couple of examples of what makes it so powerful.
Look, in the real world, things go wrong. Programs have to deal with all kinds of errors. A file goes missing, the internet connection drops, a user types in their name where their age should be. A good program doesn't just, fall over and die. It handles it. And Java has a really robust, powerful system for this, called exception handling.
And it's a pretty clever system. You basically tell the program, hey, I want you to try running this piece of code, but just be aware it might fail. A classic example is trying to divide a number by 0. You can't do that. Now, if an error happens, the program doesn't crash. Instead, a little catch block acts like a safety net. It catches the error and you, the programmer, can decide what to do next, maybe show a nice message to the user. It's what keeps applications from just blowing up. Another huge thing Java did was help move programming out of the dark ages of just text on a black screen. It gave developers the tools they needed to build rich, graphical user interfaces, what we call GUIs. We're talking about all the windows, the buttons, the menus, basically everything we click and interact with on our computers every single day. We totally take it for granted now. And it did this by providing these huge libraries of pre-made parts. Think of it like a giant box of digital Legos. Programmers could just grab things like labels for text, buttons to click, scroll bars, text fields, all the stuff we recognize, and assemble them into a working application. These components are literally the building blocks of the modern apps we use. So that brings us to the big question, right? After all this time, we're talking decades. Why is Java still one of the most popular and important programming languages on the entire planet? Well, the answer really goes back to the core ideas it was built on from day one. These things right here, they're often called the Java buzzwords, and they are the secret to why it has lasted so long. We've already talked about how being object-oriented helps tame complexity, and how being platform-independent was a total game changer for the internet. But when you add in that it's also known for being incredibly robust, meaning stable, and secure, and portable, you start to realize something. This thing was designed to last. Its foundations were just rock solid from the very beginning. And Java hasn't just stood still, it has constantly evolved, always adding new features to keep up with the insane demands of the modern tech world. It has proven time and time again just how resilient and adaptable it is. And that leaves us with one final, really interesting question to think about. After shaping so much of our digital past and our present, what on earth is this digital giant going to build for us next?